Okay, lesson 2.2, biconditionals and definitions. Our objectives are to write biconditional statements and recognize good definitions. So let's get started with vocabulary and key concepts. The first is a biconditional statement. A biconditional statement combines if P then Q and if Q then P, and says it says P if and only if Q. Okay, so an example of a biconditional statement is an angle is a straight angle if and only if its measure is 180 degrees. The if and only if is what tells us that we can write the statement both forward and backwards. They write it P with a double arrow Q, and it's read P if and only if Q. So the if and only if is the important part of a biconditional statement. It's what makes it a biconditional statement. Okay? A biconditional statement is a statement that connects the conditional and its converse. So writing it forwards and backwards. So if we look at that example up here, we could say if an angle is a straight angle, then its measure is 180 degrees. If an angle measures 180 degrees, then it is a straight angle. We know both of those statements are true, so we can write the if and only if statement. A biconditional contains the words if and only if. Anytime you see if and only if, that's a biconditional statement. Okay, let's try some examples. So, first they give you this statement, if x equals 5, then x plus 15 equals 20. And we're going to write the converse. So we're going to switch the hypothesis and the conclusion here. So I'm going to say if x plus 15 equals 20, then x equals 5. When you subtract 15 from each side to solve the equation, you get x equals 5. Okay, so because both the conditional statement, so this first statement, and its converse are true, you can combine them in a biconditional statement using the phrase if and only if. So when we go to write this, we would say x equals 5 if and only if x plus 15, equals 20. And that is our biconditional statement, because we're saying that it's true both ways, so it can be an if and only if statement. All right, separating the biconditional into two parts. Lines are skew if and only if they are coplanar. So we want to write this as a conditional statement. So I'm going to say if lines are skew, then they are non-coplanar. Okay, all I did was put if in front, get rid of the if and only if, and put then. So now I need the converse. I need to switch the hypothesis and conclusion. If lines are non-coplanar, then they are skew. That's all there is to it. Okay, let's keep it going with example 3 here. Writing a definition as a biconditional. Show that this definition of a triangle is reversible, then write it as a true biconditional statement. So when we want good definitions, we want something that we can write the definition forwards and backwards, and both are true. So, the definition, a triangle is a polygon with exactly 3 sides. We know that definition, the original conditional statement, is true. They rewrote it for us. If a polygon is a triangle, then it has exactly 3 sides. The converse is also true. And the converse is if a polygon has exactly 3 sides, then it is a triangle. So all we did was flip these 2 pieces. Okay? Because both of these statements are true, they can be combined to form a biconditional statement. So I will say a polygon is a triangle if and only if it has exactly 3 sides. That is all there is to it. And this one, they told you this was a good definition. Sometimes you'll have to check, so you'll try to say it forwards and backwards, and if one of the parts is false, then it's not a good definition. Okay, now identifying a good definition. Is the following a good definition? An apple is a fruit that contains seeds. That statement is true. That's a true description of the apple. Now we're going to switch this around. We're going to switch an apple with a fruit that contains seeds. So, a fruit that contains seeds is an apple. If the fruit contains seeds, does it always end up being an apple? No. There's all kinds of fruits that contain seeds, right? So, there are many fruits that contain seeds but are not apples, such as lemons and peaches. These are counterexamples because they prove it wrong. So the converse of the statement is false. When we switch to the hypothesis and conclusion, the statement was false. The original statement, so what we started with up here, is not a good definition because the statement is not reversible. So you want to be able to say it, take the original statement and flip it, and it still be true. Then it's a good definition. Okay, what I need you to do is these check for understanding problems. First one, consider the true conditional statement, write its converse. If the converse is also true, combine the statements as a biconditional, and they give you the statement right here. So you're going to flip the hypothesis and conclusion, decide if that's true, and if it is true, then you're going to write the biconditional statement. Write 2 statements that form a biconditional about integers greater than 1. So there are 2 statements in this sentence. You need to separate them into the 2 parts. So you're just breaking the biconditional down. Then number 3, show the definition of a right angle is reversible. Then write its true biconditional. So write this as a biconditional statement, or as a conditional statement, sorry. So I would say if an angle is a right angle, then its measure is 90 degrees. Okay, then you can write the converse of that statement down here, and you decide if these two statements are true or false, and then if they're true, you can write the biconditional of those. And last but not least, is the following a good definition? Explain. A square is a figure with 4 right angles. So you're going to decide if it's true forwards and backwards. If it is, then you're going to say, yes, it's a good definition. You can flip it around. If it's not, you're going to explain why. And that should be the lesson. So go ahead and get started.